What if the key to cooling our overheated planet lies in mimicking the fury of a volcanic eruption? What if humanity's salvation comes wrapped in the smoke, ash, and sulfur that once brought civilizations to their knees? And what if the very attempt to engineer such a solution cracks open risks so great that the Earth itself becomes a dangerous experiment? The image of Earth cracking beneath volcanic pressure is more than a metaphor. It is a window into one of the most radical proposals for intervening in the climate crisis. For decades, scientists have studied the impact of volcanic eruptions on global temperatures. When Mount Pinatubo erupted in 1991, it ejected 20 million tons of sulfur dioxide into the stratosphere, forming reflective aerosols that cooled the planet by nearly half a degree Celsius for more than a year. This single event demonstrated the awesome cooling power of volcanic processes. And now some believe humanity can replicate that effect deliberately, using technology to scatter reflective particles high above the Earth, blocking a portion of incoming sunlight. The concept, known as stratospheric aerosol injection, has become the centerpiece of one of the most controversial branches of geoengineering. Supporters argue that such interventions could provide humanity with a climate pause button. If temperatures continue to rise unchecked, triggering mass migrations, crop failures, and ecosystem collapse, then deploying artificial volcanoes in the sky could buy precious time. Unlike emission reductions, which take decades to show results, stratospheric aerosols could cool the planet within a year of deployment. This speed is both the technology's greatest appeal and its most dangerous quality. By altering one of Earth's most fundamental systems, its radiation balance, humanity would be venturing into uncharted territory with profound risks. The mechanics of stratospheric aerosol injection are deceptively simple. Aircraft or high-altitude balloons would disperse fine particles, often sulfur-based, into the stratosphere. These particles would reflect sunlight back into space, reducing global temperatures. In theory, the cost could be relatively low compared to other climate measures, tens of billions annually rather than the trillions required for a complete energy transition. But the simplicity masks staggering complexity. Earth's climate is not uniform, and the cooling effects would not be evenly distributed. Some regions might benefit, experiencing relief from extreme heat. Others might suffer catastrophic shifts in rainfall patterns, leading to droughts or floods. A solution for one continent could spell disaster for another. This is where the metaphor of a cracked planet becomes stark. Imagine a world where deliberate injections of aerosols cool Europe and North America, but disrupt monsoons in South Asia, depriving millions of farmers of reliable rain. Or a scenario where African nations experience prolonged drought while wealthier countries reap the benefits of a stabilized climate. The technology that promises a global fix could fracture the planet along lines of inequity, deepening existing divisions and sparking new conflicts. In this sense, the volcanic future of climate intervention carries not just environmental risks, but geopolitical ones. The political dimension is critical. Who decides when and how to deploy such technology? If one nation, or even a coalition, unilaterally begins aerosol injection, it could trigger outrage from others affected by unintended side effects. Unlike carbon emissions, which are diffuse and cumulative, the impacts of stratospheric aerosols could be immediate and localized. Nations suffering from drought or disrupted agriculture might blame the injecting states, whether or not the science supported their claims. The potential for international conflict is immense. Climate intervention at this scale could become a weapon, or at least be perceived as one. It is not difficult to imagine accusations of climate warfare in a world where the weather itself can be manipulated by policy. Then there is the issue of dependency. Once deployed, stratospheric aerosol injection cannot easily be stopped. The particles would remain in the atmosphere only temporarily, meaning constant replenishment would be required. If the program were suddenly halted due to political upheaval, financial collapse, or sabotage, the planet could experience termination shock. Decades of suppressed warming would return in a matter of years, producing a spike in temperatures far more destructive than the gradual increases we now face. Ecosystems already under stress would collapse. Human societies, unprepared for such abrupt change, would endure catastrophic shocks. This creates a dangerous dynamic where future generations could become locked into a system they never chose, forced to maintain artificial volcanoes for centuries. Critics also highlight the ecological risks. While volcanic eruptions cool the planet, they also damage ecosystems. Pinatubo's eruption thinned the ozone layer, increasing ultraviolet radiation. Artificial aerosols could replicate this effect, jeopardizing global health and agriculture. Acid rain, altered cloud formation, and unforeseen chemical interactions add further layers of risk. And while cooling might slow ice melt, it would do nothing to address ocean acidification caused by rising CO2 levels. In other words, the volcanic approach masks symptoms without curing the disease. It cools the surface but leaves deeper ecological damage unchecked. Yet the temptation remains strong. Humanity is running out of time. Emissions continue to rise, and international agreements struggle to enforce meaningful cuts. Extreme weather events multiply, costing trillions and displacing millions. In this context, stratospheric aerosol injection offers a vision of hope, a technology that could be deployed quickly, at scale, and with dramatic results. For nations desperate to protect their people from escalating disasters, the gamble may seem worth it. The volcanic future of climate intervention, once dismissed as science fiction, is inching closer to reality. The public perception of such interventions is equally important. The idea of deliberately replicating volcanic eruptions unsettles many. For some, it represents human ingenuity at its boldest, taking control of the climate to avert catastrophe. For others, it feels like hubris, a dangerous overreach that ignores nature's complexity. Cultural narratives shape these perceptions. In Western traditions, humans often view themselves as masters of nature, entitled to engineer solutions. In indigenous worldviews, nature is not a machine to be manipulated, but a living system demanding respect. The clash of these perspectives adds another layer to the debate, highlighting that the decision to pursue volcanic-style interventions is not just scientific, but philosophical. Economics adds further complexity. While aerosol injection may seem affordable compared to decarbonization, the true costs remain unknown. Who pays for the program? How are the costs of unintended damage calculated, and who compensates the victims? Private companies might see opportunities to profit, raising the risk of commercialization and lobbying. Imagine corporations selling climate control as a service, offering wealthy nations customized cooling while poorer countries suffer side effects. The commodification of the atmosphere would represent a new frontier in inequality, deepening the cracks already visible in global justice. There is also the issue of distraction. Some fear that the promise of geoengineering will reduce the urgency of cutting emissions. If leaders believe they can deploy aerosols to cool the planet, will they slow efforts to transition to renewable energy? Will fossil fuel companies exploit geoengineering as a justification to continue extraction? History suggests this is a real danger. Humanity often chooses short-term convenience over long-term discipline. The risk is that the volcanic future becomes not a bridge to sustainability, but a crutch that perpetuates dependence on the very systems causing the crisis. Despite these dangers, many scientists argue that research into stratospheric aerosols is necessary. Ignoring the option does not make it disappear. It only ensures that if the technology is ever deployed, it will be done in ignorance. Careful, transparent, small-scale experiments could provide valuable data about risks and benefits. International frameworks could establish guidelines and governance, reducing the chance of unilateral action. The debate, then, is not about whether to study the volcanic future, but about how to do so responsibly. Research must proceed with humility, transparency, and global participation. At the heart of this debate lies a paradox. Humanity seeks to control nature at the very moment nature is reminding us of its uncontrollable power. Volcanic eruptions, hurricanes, and rising seas demonstrate the scale of Earth's systems. By trying to replicate volcanic processes, humans may reveal both their technological brilliance and their fragility. We can mimic eruptions, but we cannot command their outcomes. The cracked planet is not only a symbol of physical risks, but a mirror of our fractured relationship with nature itself. The future of climate intervention may not be a binary choice between aerosols and emissions cuts. Instead, it may involve a complex mix of mitigation, adaptation, and cautious research into geoengineering. Emissions reductions remain essential. Without them, no amount of aerosol injection can prevent ocean acidification or the long-term accumulation of greenhouse gases. Adaptation measures, like resilient infrastructure and agricultural innovation, are equally critical. But in a world where climate impacts are accelerating, pressure to explore volcanic-style interventions will only grow. The key is to ensure that this exploration does not fracture the planet further, politically or environmentally. Ultimately, the volcanic future forces us to confront a deeper question. How far should humanity go in reshaping Earth to secure its survival? The desire to cool the planet is understandable, but so is the fear that in doing so we unleash consequences we cannot control. The cracks in planet Earth are not just geological, they are ethical, political, and generational. Whether humanity survives this future will depend not only on the brilliance of its machines, but on the wisdom of its choices. The image of a cracked Earth, cooled by artificial volcanoes but fractured by injustice and unintended consequences, is both a warning and a challenge. If we are to navigate the volcanic future of climate intervention, we must do so with humility, justice, and foresight. The eruption has not yet begun. The question is whether we will trigger it ourselves, or find another way to cool the flames we have set in motion. The volcanic vision of climate intervention, with stratospheric aerosols mimicking eruptions like Mount Pinatubo, sits at the intersection of hope and fear. Part 1 laid the foundation by exploring the mechanics and immediate risks of stratospheric aerosol injection. In Part 2, we must widen the lens, examining how such a radical approach reshapes geopolitics, justice, science, and society. The metaphor of a cracked planet takes on new dimensions here, not only describing fractured ecosystems, but also the splintering of global trust, values, and futures. The volcanic future is not only about sulfur in the sky, it is about the political tremors and ethical fissures it may unleash. The geopolitical stakes are enormous. Climate intervention at planetary scale is not something that can be neatly contained within national borders. If one nation or coalition of nations decided to deploy stratospheric aerosols, the effects would ripple across every corner of the globe. Rainfall might decline in one hemisphere while increasing in another. Monsoons, critical for billions of people in South Asia, could weaken or shift, destabilizing food supplies. Crop yields in Africa could plummet, while Europe might experience milder climates. In this scenario, blame becomes inevitable. Countries suffering negative outcomes would point fingers at those who deployed the technology, accusing them of weaponizing the climate. Even if the science were uncertain, the perception of responsibility would be enough to ignite diplomatic crises. This is not a distant hypothetical. History shows that nations already accuse one another of manipulating the environment. During droughts, governments sometimes blame foreign projects like cloud seeding. The introduction of large-scale stratospheric injection would amplify such suspicions exponentially. The international system, already strained by trade wars, military conflicts, and resource disputes, could fracture further under the weight of climate manipulation accusations. In extreme cases, aerosol deployment could become a trigger for war, either because it is used as a deliberate weapon or because it is perceived as one. The cracked planet here is not just physical but political, marked by deepening divisions and the erosion of trust. The governance challenge is equally daunting. There is currently no binding international framework to regulate geoengineering at this scale. Climate treaties like the Paris Agreement focus on emissions reductions, not deliberate interventions in Earth's radiation balance. The United Nations has convened discussions, but consensus remains elusive. Who would oversee aerosol deployment? How would decisions be made about how much to inject, when to begin, and when to stop? These are not technical questions alone. They are questions of sovereignty, equity, and global justice. Without robust governance, the risk of unilateral action looms large. Imagine a desperate country facing lethal heat waves or crop failures, deciding to act on its own, deploying aerosols in the stratosphere without permission. The global consequences of such desperation could be catastrophic. Then comes the ethical labyrinth. Geoengineering, by its nature, redistributes risks and benefits unevenly. Some regions may cool in ways that stabilize agriculture and ecosystems. Others may face droughts, floods, or shifts in weather patterns that destroy livelihoods. This asymmetry forces humanity to confront the question: whose suffering is acceptable in the pursuit of a global good? Is it justifiable to protect cities in the global north while villages in the global south starve? The cracked planet is also a fractured moral landscape, where justice is uneven and consent is absent. Future generations bear the heaviest burden of all. If aerosol injection begins, they inherit the obligation to continue it indefinitely or risk termination shock. Can one generation ethically impose such a dependency on another? The question of intergenerational justice hangs over the volcanic future like ash after an eruption. Science, too, finds itself stretched to its limits in this debate. Climate models can simulate the effects of aerosol injection, but they cannot predict every outcome. Earth systems are too complex, too nonlinear, too interconnected. Unintended consequences are inevitable. Feedback loops could amplify effects in unexpected ways. For example, aerosols might cool the planet, but disrupt ocean circulation, altering nutrient flows critical to marine ecosystems. Or they might interact with clouds in ways that accelerate warming in some regions, rather than reduce it. The cracks in scientific certainty mirror the cracks in political unity, leaving humanity to make decisions under a shadow of uncertainty. In such a setting, caution seems prudent, but desperation often drives recklessness. The social consequences of a volcanic climate intervention are profound. Public perception will play a pivotal role in shaping the future of geoengineering. If aerosol injection is portrayed as a miracle solution, public support might grow quickly, especially in nations already suffering from climate disasters. On the other hand, if early trials produce negative side effects, or if communities feel excluded from decision-making, backlash could erupt. Protests, legal challenges, and political opposition could stall programs or even trigger violent unrest. The cracked planet also manifests socially in fractured public trust and growing divides between those who see intervention as salvation and those who see it as betrayal. Economics adds another layer of complexity. Stratospheric aerosol injection is often touted as relatively cheap, tens of billions of dollars annually compared to the trillions needed for decarbonization. But this framing is misleading. The true costs include unintended damages, agricultural losses from disrupted rainfall, health impacts from increased ultraviolet radiation, ecological collapse in vulnerable regions. Who pays for these damages? How are costs distributed? The absence of economic frameworks for compensation reveals another fracture in the planetary system. Without global mechanisms to account for damages, the victims of geoengineering will likely remain uncompensated, deepening global inequalities. Corporate involvement raises new concerns. As the climate crisis worsens, private companies may step into the geoengineering space, promising quick fixes. Tech entrepreneurs already discuss funding small-scale trials of aerosol injection. While innovation is vital, profit-driven motivations pose risks. Companies might downplay dangers, lobby against regulations, or rush deployment to gain competitive advantage. The commodification of the atmosphere, where climate stability becomes a market product, could fracture the planet into winners and losers. Wealthy nations might afford customized cooling, while poorer nations are left to suffer side effects. The cracked planet here becomes an image of economic injustice, where the climate itself becomes a domain of inequality. The ecological risks also extend beyond human society. Volcanic eruptions remind us that aerosols damage ecosystems. Pinatubo thinned the ozone layer, increasing ultraviolet radiation. Artificial aerosols could replicate this effect, threatening crops, fisheries, and human health. Acid rain, caused by sulfur particles, could harm forests and freshwater systems. Biodiversity, already under siege from climate change, might collapse further under the strain of engineered interventions. Coral reefs, weakened by warming and acidification, may not survive additional disruptions. The cracked planet here represents a fractured biosphere, where ecosystems unravel under the combined weight of natural stress and human manipulation. Despite the risks, many argue that research into aerosol injection is unavoidable. Ignoring the option does not eliminate it. In fact, it increases the chance that desperate nations or corporations will deploy it recklessly, without sufficient knowledge. The prudent path, some suggest, is to pursue transparent, internationally governed research programs that explore the risks and limits of the technology. Small-scale trials, carefully monitored, could provide valuable data. But transparency and inclusivity are essential. Without them, research itself could fracture global trust, with communities suspecting secret experiments or hidden agendas. The cracked planet is as much about mistrust as it is about sulfur in the sky. There is also a psychological dimension to the volcanic future. Humans have long sought control over nature, from taming rivers to building dams, from modifying crops to engineering ecosystems. Aerosol injection represents the ultimate extension of this impulse, controlling the very sunlight that sustains life. For some, this ambition is thrilling, proof of human ingenuity. For others, it is terrifying, evidence of hubris. Public attitudes will shape political decisions, which in turn will determine whether geoengineering proceeds. The cracked planet is therefore also a fractured imagination, divided between those who see control as survival and those who see it as destruction. The cultural perspective adds further depth. Different societies view nature in different ways. Western industrial cultures often see it as a system to be optimized, while indigenous cultures emphasize reciprocity and balance. Introducing volcanic-style interventions without acknowledging these perspectives risks repeating patterns of colonialism and domination. Climate manipulation could become another instance of powerful nations imposing their values and solutions on vulnerable communities. Respecting cultural diversity and listening to marginalized voices will be crucial in navigating the volcanic future. Otherwise, the cracks of inequality and exploitation will widen into chasms. What emerges from all these dimensions? Geopolitical, ethical, scientific, social, economic, ecological, psychological, cultural, is a picture of immense complexity. The volcanic future of climate intervention is not a single crack in planet Earth, but a network of fractures running through every layer of our global system. To navigate this future responsibly, humanity must confront these fractures directly, not paper over them with promises of quick fixes. It must invest in research, governance, justice, and cultural humility, recognizing that the stakes are nothing less than planetary survival. The cracked Earth metaphor is not simply a warning. It is also a call to reflection. Cracks reveal weakness, but they also reveal the internal structure of what they split. The debate over stratospheric aerosols reveals the structure of our civilization, the imbalance of power, the inequities of wealth, the limits of science, and the fragility of ecosystems. If humanity learns from these cracks, it may yet avoid catastrophic collapse. If not, the volcanic future could erupt not only in the skies, but in the very fabric of human society. The choices are stark. Embrace the volcanic path recklessly and risk unleashing new disasters. Reject it entirely and risk being unprepared for desperation-driven deployment. Explore it cautiously, transparently, and inclusively, and there may be a chance to understand its limits without crossing the point of no return. Whatever the choice, the cracks in planet Earth remind us that climate intervention is not just about technology. It is about humanity's capacity for wisdom, justice, and restraint in the face of crisis. Part 3 of this exploration of the volcanic future of climate intervention brings us into the most critical arena, the human confrontation with risk, responsibility, and the choices that will shape our planetary destiny. The metaphor of cracking planet Earth is no longer a distant vision, but a vivid possibility. As humanity debates whether to mimic volcanic eruptions with stratospheric aerosols or other forms of geoengineering. The cracks are physical, as ecosystems strain under both natural and artificial disruptions. They are political, as nations wrestle over sovereignty and blame. They are ethical, as generations confront decisions imposed upon them without consent. And they are cultural, as humanity struggles to define what it means to live in harmony with or in defiance of nature. The first and most pressing issue is responsibility. If humanity chooses to deploy stratospheric aerosol injections, who bears responsibility for the outcomes? Is it the scientists who proposed the idea, the politicians who authorized it, the engineers who built the delivery systems, or the public who demanded quick solutions to escalating climate disasters? Responsibility is diffuse, spread across networks of power and influence. Yet when crops fail, when droughts deepen, or when rainfall patterns shift catastrophically, people will look for someone to blame. The cracked Earth will become a cracked society, with trust eroded and accusations flying. History shows that when disasters strike, accountability is rarely shared fairly. Those most vulnerable, the poor, the marginalized, the powerless, will likely bear the brunt of suffering, even though they had little voice in the decision to engineer the climate. This leads to the second issue: justice. Climate intervention is not just a scientific experiment, but a moral dilemma. Deploying artificial volcanic eruptions may protect certain regions while devastating others. It may cool urban centers in wealthy nations while triggering agricultural collapse in rural economies of the global south. The unevenness is not accidental, but structural, built into the complexity of Earth's systems. The question then becomes, who decides whose suffering is acceptable? Without a robust global governance framework, the answer will be determined by power, not justice. The cracked Earth will reflect cracked ethics, where the lives of some are valued more than others. Intergenerational justice compounds this problem. If stratospheric aerosols are deployed, future generations inherit the burden of maintaining them indefinitely. If they stop, termination shock could devastate the planet with sudden, rapid warming. Can we, in good conscience, bind billions of unborn people to a technological dependency they never chose? The volcanic future demands not just technical debate, but deep ethical reckoning. The third issue is dependency itself. Unlike natural volcanic eruptions, which fade with time, artificial aerosol programs would need to be continuous. This creates a kind of technological addiction. Once humanity begins injecting particles into the stratosphere, stopping becomes almost impossible without triggering catastrophic rebound warming. This dependency would transform global politics. Nations would argue over how much aerosol to release, where to release it, and who controls the machinery. Sabotage, conflict, and mistrust would hover over every decision. The planet would become hostage to machines in the sky, machines that could never be turned off. The cracks in planet Earth would also be cracks in freedom, as humanity ties itself to a system it cannot abandon. The fourth issue lies in knowledge. Science provides models and predictions, but it cannot guarantee certainty. Feedback loops and non-linear responses mean that unintended consequences are inevitable. The volcanic future is therefore a leap into the unknown. Some argue that research and small-scale experiments could reduce this uncertainty, giving humanity tools to decide responsibly. But research itself is fraught with risk. Even small tests might produce side effects, and public suspicion of hidden agendas could derail trust in science altogether. Knowledge, once considered humanity's shield, becomes part of the fracture, with competing interpretations fueling division. Some will argue that models justify deployment. Others will argue that the same models prove its danger. In the battle of narratives, science risks becoming politicized, another crack in the foundation of global cooperation. Fifth, the ecological stakes cannot be ignored. Stratospheric aerosols may cool the surface, but they could damage the ozone layer, increasing harmful ultraviolet radiation. They could alter rainfall, harm ecosystems, and disrupt biodiversity. Acid rain could weaken forests and soils. Marine systems, already strained by acidification and warming, might collapse further under new stress. Nature, in this scenario, is not a passive recipient, but an active force pushing back against human interventions. The volcanic future is not a simple fix, but a gamble with life's intricate web. The cracks in planet Earth could widen into rifts that unravel entire ecosystems. Humanity may discover too late that by trying to control nature, it has provoked responses beyond its capacity to manage. And yet, even amidst these risks, the volcanic future remains tempting. The climate crisis is accelerating. Every year brings new records: hottest summers, strongest storms, most destructive wildfires. Millions are displaced, billions are affected, trillions are lost in damages. In this context, the appeal of a technology that could cool the planet quickly, at relatively low cost, is undeniable. Leaders facing desperate populations may choose intervention not out of arrogance, but out of necessity. This urgency makes the debate even more urgent. The volcanic path is not a distant choice. It is one that could be taken in the next decade. The cracks are forming now, in the pressure of politics, economics, and public demand. The cultural dimension is often overlooked, but deeply important. Different societies frame the relationship between humans and nature in different ways. In some, nature is seen as a system to be engineered and controlled. In others, it is a sacred balance to be respected. The volcanic future, with its emphasis on control and manipulation, reflects one worldview but marginalizes others. Indigenous perspectives, which emphasize reciprocity and stewardship, may offer alternative paths. Ignoring these voices risks repeating colonial patterns of domination, where powerful nations impose their vision of solutions on vulnerable communities. The cracked planet, in this sense, also symbolizes a cracked cultural dialogue, where wisdom and diversity are silenced in favor of narrow visions of control. Economics cannot be separated from this story. The projected costs of aerosol injection are relatively low, but the hidden costs, damages, health impacts, political instability are vast. Corporations may see opportunities for profit, offering climate control as a commercial service. Wealthy nations might fund programs that protect their interests while exporting risks to others. The global atmosphere could become a marketplace, with justice and equity sidelined. The cracked Earth becomes a fractured economy, where survival is commodified and inequality entrenched. Unless international frameworks address these imbalances, the volcanic future will deepen divisions between rich and poor, north and south. So what is the way forward? One option is outright rejection, declaring stratospheric aerosols too dangerous and focusing exclusively on emissions reduction and adaptation. Another is reckless deployment, driven by desperation in the face of escalating disasters. Both extremes carry dangers. The middle path, cautious, transparent, internationally governed research, may be the most responsible. Humanity must understand the risks before deciding whether to act. Small-scale trials, subject to strict oversight, could provide critical data. But such research must include broad participation, especially from vulnerable communities. Transparency and inclusivity are not optional. They are essential to legitimacy. Without them, the volcanic future will fracture trust beyond repair. At the heart of this debate lies a profound question. What does it mean to be human in the Anthropocene? Do we define ourselves as engineers of Earth, bending the planet to our will? Or do we accept limits, living within nature's boundaries rather than overriding them? The volcanic future of climate intervention forces us to confront these identities. One path risks control that turns into catastrophe. The other risks restraint that may not come fast enough to prevent suffering. The cracks in planet Earth are also cracks in our self-understanding, forcing us to choose what kind of species we want to be. And now, the call to action. This is not a debate to be left to scientists or politicians alone. The decision to engineer the planet's climate will affect every human being, every ecosystem, every generation to come. You have a role in this. Stay informed. Demand transparency in climate policies. Question narratives that present quick fixes as miracle solutions. Support efforts to cut emissions, build resilience, and invest in renewable energy. Push your leaders to prioritize justice and equity in global negotiations. Share knowledge, start conversations, and refuse to look away from the stakes. The volcanic future is not predetermined. It is one possible path among many, shaped by human choices. If society remains silent, decisions will be made behind closed doors, perhaps recklessly. But if citizens demand accountability, if communities raise their voices, if cultures share their wisdom, the cracks in planet Earth may yet be healed rather than widened. Crisis Lens exists to bring these questions into the light, to give you the tools to understand and the courage to act. The climate crisis is the defining challenge of our time, and geoengineering is one of its most explosive frontiers. But the future is not written. It will be forged by those who choose to engage, to question, and to act. Subscribe to Crisis Lens, share this video with those who need to understand the stakes, and join the conversation. The cracks are forming now, but together we can decide whether they become fractures of collapse or openings for transformation. The choice is ours. What role will you play?